everyone, and welcome to the second installment of our Mythbuster Monday series. I am lucky today to be joined by Saravanan Thangamani, who is here to share some of his 20 years of tick expertise with us and clear up more misconceptions about ticks and Lyme disease. So take it away.
Hi, good morning, and thanks for having me. I'm glad to share or glad to butt some myths about ticks and tick-borne diseases. So I have listed 3 misconceptions about ticks and tick-borne diseases. So I'll go over one by one. The first one is only female ticks bite and transmit diseases. It is not true. Both males and females can actually feed on a human and transmit a disease, but only females would feed for longer duration, which means that females can actually feed for 3 to 5 days. However, males only will feed for 1 to 2 days. So the main purpose of the male to feed on a female is to mate with the female, and that's the only thing. So when a male sends a signal to the female during the mating process, that in a way sends a signal to the female, all right, now I'm ready to feed and engorge hugely big. So basically it's more of a signal transmission that is happening. So male's primary purpose is actually to feed a little bit and then mate with a female. Female then takes care of the entire process. So long story short, both male and female transmit disease and feed on humans. However, females feed for the longest duration, males feed only for the shortest duration. And males and females are only differentiated in the adult stage. So the larval tick and the nymphal tick are asexual, which means there is no male-female differentiation. The male-female differentiation happens only in the adult tick population. So that's the misconception, number 1. Number 2, the common misconception is that you will not feel the pain when a tick bites you. Well, I have to revise it. You will feel the pain when the tick bites you. That's a misconception, but it's not true. Ticks are very smart. They will not cause any pain. Although they cause severe injury to your skin, they take your blood for 5 to 7 days, they will not cause any pain sensation to you because they're very smart. They may be very little, but they are very smart critters. And I can show you an image just to kind of illustrate how smart they are. Let me share my screen here. All right, I'm sharing my screen now. Okay, so these are the tick salivary glands. So what happens when a tick is attached to a human is that ticks initially injects cement protein so that they can anchor and attach to a human skin. And then it starts to secrete some chemicals at the feeding site in such a way it numbs the site. So from the time it comes in contact with the skin, we don't feel any pain because it numbs the place. It anesthetizes that particular site, so we don't feel anything. And it continues to inject that anesthetic compounds throughout the feeding time in such a way that we don't feel any pain at all. So on the screen here, you see the day 0 tick. These are the naive female tick, actually never actually attached to a human. And on the right side is the salivary glands of the tick that are 5 days post-attachment. So we can imagine, look at the image, it's almost like many times larger, which means that they continue to secrete these salivary proteins into the skin in such a way it numbs everything. And it does a lot of other properties, a lot of other activities, but the primary thing is it numbs the pain. So we don't sense anything, because when we sense something, when we sense a pain, we normally kind of go to the spot and try to clear it off, right? So they know that if they induce pain to humans, humans will pick the tick easily. So they kind of circumvent that by injecting pain-killing chemicals into our body. So that's the second misconception. The third one is, once you're bitten by a tick, you will get transmitted by a tick-borne disease agent. In other words, once bitten, you will get a disease. It is not true. As we all know that not all ticks carry diseases or disease-causing agents. I can use Lyme disease as an example here. So not all ticks carry Lyme disease agent, the Borrelia burgdorferi. Only depending on the regions where we are, I would say that, because we are in Onondaga County, so I can tell that for Onondaga County, anywhere from 30 to 40% of the ticks are positive for the Lyme disease bacteria. So the rest 60% doesn't carry anything, right? So only 40% of the ticks will transmit a disease. The second thing is, not all tick bites will result in tick-borne disease transmission, because the next slide I'm going to show is this one. So this illustration clearly tells different disease-causing agents are transmitted at different times post a tick attachment on a human skin. So as you would see here in this picture, tick-borne encephalitis or Powassan virus circulates in our area. It is immediately transmitted to the human. However, Anaplasma or Rickettsia or Borrelia, they require around 24 to 48 hours to be transmitted. The primary reason is that when a tick feeds on a human, it takes the blood, and then the blood goes to the gut. And the Borrelia tick-borne bacteria, they stay in the gut in a normal tick. They don't actually migrate to the salivary glands. So when the blood goes in, it sends signal to the ticks, hey, it's time for the Borrelia to get out of the gut. So it secretes certain signals in such a way that the Borrelia multiplies in the gut and then escapes the gut. When I say gut, it's the stomach of the tick. And then it moves to the salivary gland. And once it goes to the salivary gland, it is then deposited into the skin. And that's when the transmission happens. So for this entire event to happen, it takes about 24 to 48 hours. And that's why there is a delay in the transmission from the time of attachment to the time of Lyme disease agent delivery. However, viruses are different. So we need to understand that depending on the time, how long it was attached to a human, the risk of acquiring a disease is high or low, depending on how long it's on the skin. And I want to kind of show a picture that we did in our lab. On the left side, you see actually a tick. This is a tick hypostome, tick mouthparts. And these are tick cement. And you can see right below the feeding side, I hope that you can see clearly, these are pink cells that are colored in pink. Those are the cells that actually carry the virus. And on the right panel, you can see clearly the ones with the left pointed red arrows, those cells are positive for the tick-borne virus, very similar to the Powassan virus. And this was taken 3 hours post-attachment. So you can see how many cells are actually positive to the virus. However, at this time, we would not see a Borrelia infection there. So that's what I wanted to kind of differentiate the differences. And these are the three misconceptions I have for this Monday.
Well, thank you so much. There's a lot more to it than just the tick attaching to your skin. It was interesting to hear about the staggering times that it can take for the disease or the pathogen to actually enter your cells and infect your cells. And I hope that everyone has learned a little bit and has clarified some of the misconceptions and misinformation that's out there. And Saravanan, I really appreciate your time. Thank you so much.
Thank you. Really appreciate that. All right.
Bye now.